For section 4.3, if you remember last lesson, we were saying we're going to go over all the rest of the derivative rules for sinusoidal functions. So we're going to go back and look at the rules from chapter 2 and then apply those to sinusoidal functions like in the examples below. So some key ideas to start. If we have f of x and g of x are differentiable functions, right? Then the power rule would state that if I have y equals x to the power of n, then the derivative of that, y prime, would be bring the exponent out in front, right? And do one less on the exponent. The product rule, if y is equal to f of x times g of x, so two different functions, then to the product rule is to get the derivative y prime, I get the derivative of the first times the second the way it is, and make sure it's adding. Then the derivative of the second term times the first the way it is, right? And for the product rule, I have the product of two functions here. Just to go over, it can only be two functions. I can't have 3 terms or 4 terms multiplied together and have this same rule. This only applies to 2 parts. The quotient rule, again, means dividing. So if I have a function as a numerator over top of a different function as the denominator, then to get the derivative of that, I get the derivative of the top times the bottom the way it is. In this case, I'm subtracting all the time, right? Derivative of the bottom times the top the way it is all over the bottom squared. We did that one not too long ago, right? Then we have the chain rule, which is if I have a function within a function. So then to get the derivative of those two functions, basically I get the derivative of the outer function first. I leave the inner alone. Then I get the derivative, multiply it by the derivative of the inner function. So do the outer, leave the inner, and then multiply by the derivative of the inner. The power chain rule, if I have a function and that's placed in brackets to an exponent, then again, to get the derivative of that function, I bring the exponent out in front like always, leave the function the way it is, do one less on the exponent, but then multiply that by the derivative of the inside, the derivative of the inner function, okay? So let's do some examples here. I think I'm just gonna move this up to try to fit all 4 in at once. So if I have here y equals cos like the cos of negative pi x. So again, after I have my function, what's in the brackets afterwards, that's like my angle, right? So in this case, we would be doing chain rule here. So to get the derivative y prime, I would get the derivative of the outside, right? So the derivative of cos is negative sine, leaving the inside the way it is, and then getting the derivative of the inside with respect to x. So that would be a 1 there, come out in front, and I would have multiplied by negative pi, x to the power of 0, right? Which just would mean that x would go away. And then it's just a matter of simplifying this. So this is a coefficient, right? Which would end up being a constant. So I would have here, just cleaning this up, the derivative, I would have a negative multiplied by, bring the constant out in front. So a negative pi sine of, again, this angle, you leave it the way it is. You leave it together and it has to stay beside sine, negative pi x. And then again, I've got a double negative there. So that's just going to turn into pi, positive pi, sine of bracket, keep the negative pi x in brackets because that's the angle associated with my function. Okay. That one seems okay. So B, if I have sine x, the function, times cos of x, the function, so it's 2, again, it has to be 2, multiplied by each other, then I would have the product rule here. So if we go up with the product rule, derivative of the first times the second, plus derivative of the second times the first. So the derivative of the first, which is sine, the derivative of sine is cos, times the second, so times cos of x. I'm just copying that one down. Then remember, it's a plus always when I'm doing product rule. Derivative of the second guy. So what's the derivative of cos of x? Negative sine of x, right? Multiplied by the first. f of x the way it is, let's say, right? And that's it. We don't divide unless it was quotient rule. So product rule, that's it, and we add. So then it's just a matter of cleaning it up. So I have here cos of x times cos of x. So cos of x times cos of x is like cos of x squared, right? And then I have a negative times a positive times a negative here. Either way, I'll have a negative. And then I have sine of x times sine of x. So I could just turn that into a negative and then say that it's sine of x squared. And then you could leave it like that, but the way you've probably been seeing it out of your textbook is we don't usually write cos of x and then with a bracket squared, it's usually written as cos, and you saw this in grade 11 as well, cos squared of x, right? Minus then sine squared of x. So just a different notation. In terms of calculating derivatives and things, I think it would be easier. So these are kind of interchangeable. I would change it into this format to help you with getting the derivative. And then when it's completed, so for example, we'll do that in C, then you can put it back in its kind of proper form, which would be this form here. So here we have y equals 1/3 and then cos cubed of x. So that's cos of x cubed. So yes, like I said, to help with taking the derivative, let's just rewrite. I'm not getting the derivative yet. It's still y as equaling 1/3 and then just put cos of x in brackets cubed because that's going to help us to get the derivative, right? So now we see the way that it's written out this way would be the power chain rule. So to do the derivative, I bring the 3 out in front. So again, I'm not going to write this down, but just 3 times 1/3 would be 3 divided by 3 is just a 1. Again, I'm going to get rid of that eventually. And then I write out the inner cos of x and do 1 less on the exponent. So 3 minus 1 is 2. Cos of x squared. And then I do the derivative of the inner. So what is the derivative of cos of x? Is negative sine of x. And then it's just a matter of if there's any cleaning up to do, right? So here I would have, I don't need to write out the 1 and I can write this out properly, like in the proper notation, let's say is cos squared of x. And that's multiplied by, so just be careful not to put subtract, right? This is multiplied by negative sine of x. And you can totally leave it this way. But you might also see it, or in the back of the book, you might see it written as where they, because it's a negative, they just put the negative out in front. So again, just be careful if your answer is not matching the book. It could just be that it's written in a different form, but they actually write multiplied 2 times 3 or 3 times 2 is the same thing, equal to each other. So just to point that out, they might bring the negative out in front, and you can as well, or you can leave it in this form too is okay. All right, so last one here before we get into more of a word problem solving for an equation example. F of x equals negative x squared. So this negative x is not squared, sorry, is not sinusoidal, right? It's just in front. This is the sinusoidal part, and this is the angle 3x minus pi. So I have here 2 parts. So just to point out, I have the first part here, and I have a second part here, and between them is multiplying. So we're doing the product rule here. Okay. So product rule, if I'm doing the derivative, there's nothing to really rewrite there. Would be the derivative of the first, so bring the 2 out in front, so negative 2x multiplied by exactly what the second is, sine of 3x minus pi, double bracket, excuse me, plus for product rule, right? I don't know if I'm, yeah, I'll see if I can probably fit it out here. Plus the derivative of the second. So to take the derivative of the second, I take the derivative of the outer here. The derivative of sine is cos. Leave what's in the bracket, 3x minus pi, right? Then multiply by the derivative of the inside with respect to x is 3, x to the power of 0, so 3. Then don't forget to multiply it by the first part, exactly the way the first part is. No changes, no derivative, just negative x squared. Just snuck it in there. And then it's just a matter of cleaning things up here. So let's bring this over here. So negative 2x, nothing really changes in this whole first term here. So negative 2x, maybe I can get rid of the bracket if you want, sine of bracket 3x minus pi bracket. And then I could put a plus sign, but if I'm just looking ahead here, I have a positive times the constant of 3, the coefficient, plus another coefficient of negative x squared, right? So that would be positive times a negative. So that'd be negative 3x squared that I could bring out in front. And then I'm just, so that's gone. And then, yeah, I got the negative there. And then just cos of what's in the bracket, 3x minus pi. And that's about as far as I can go. I also wanted to point out, if you notice, I have a common 3x minus pi. Don't common factor that out, because if we're looking at this differently than the previous chapter, right, when we're talking about sinusoidal function, we said we have sine of this angle and we have the cos of this angle, and these are constants out in front. This whole section needs to stay together because I've got the constant and then sine of the angle. So if I factor that out, you're breaking that apart, and I don't want to break that apart when I'm talking about the information I need in order to graph my wave curves, okay? So just leave those the way it is and don't common factor that out. So I just want to delete that underline. So next question, let's clear this. We've got one more question here on the back. That's, like I said, solving for determining an entire equation, which was like our last video. Find the equation of the line that is tangent to the function. So I want the equation of the tangent line. Here's my function, all of that, evaluated at x equals pi divided by 2. So pi is 180. So that's the same thing as 90 degrees, just to point out, right? So let's write out our function like we did in the last video. So y equals the sine of 4x, and see if I want to rewrite that slightly in any other way before I start. Sine of 4x and then cos squared of x. So then I might want to write that out as cos of x squared, right? Sine of 4x times is still there, cos of x squared. I just rewrote it a little bit. So then I can see here I have two terms multiplied. I'm going to do the product rule here to differentiate. And again, I'm wanting to differentiate to plug in the value of x equals pi over 2 to get my slope, and then plug that value into the original equation. We're going to come back to here to get my y value to then sub that and get a final equation of a tangent line. So first is just to get the derivative. So product rule is the derivative of the first term, which is the outside product of, the derivative of sine is cos, right, of 4x, but then the derivative of the inside is 4. Don't forget that in respect to x, right, would be the 1 coming in front, 4x to the power of 0, and then multiplied by exactly whatever the second term is. So cos of x squared, and then add to that, that's just the whole first part, the derivative of the second. So the 2 coming in front, cos of x to the power of 1, but I don't need to write that in. And then the derivative of the inside, so the derivative of cos is negative sine of x multiplied by exactly what the first term is. So multiplied by the sine of 4x, or you could put like a double bracket there, okay? Let's go ahead, and there's not much to clean up really before we sub in the x value of pi over 2 or 90 degrees, but we can do a little bit. Every little bit helps, right? We're just putting it in the right format because our constant here should come out in front. Again, this is not a constant, that's an angle with cos. This is a function as well. This is a function, this is a function, this is the angle that's going with sine. So I have the constant of 4 and the constant of 2, and maybe the constant here of negative 1, also in front, right? Not afterwards, but out in front. So if I bring this 4 out in front, I have 4 cos of the angle 4x multiplied by, I can leave it like that, cos of x squared. Again, if I have this negative, just to point out, this negative 1 multiplied by the 2, the only constants, I could make that a negative 2, and then the rest would be the same. Here, I'm just going to put sine x cos of x, just because you're kind of used to having sine of x first. But again, you could have written cos of x multiplied by sine of x. That honestly doesn't matter. Multiplied by the sine of 4x, just copied that down. So now I'm going to evaluate, if that's as far as I can go, I'm going to evaluate at x equals pi over 2 or 90 degrees. So anytime I see x now, let's just replace it with pi over 2. 4 cos of bracket 4 times now x pi over 2 multiplied by, I'm just looking, we'll do another square bracket, cos of pi over 2, but then close the bracket and then square it, right? Minus 2 sine of pi over 2, cos of pi over 2, figure out what those values are at this radian or x degree of 90 degrees, multiplied by the sine of, again, bracket 4 times pi over 2. Nothing is squared there. And I can sort of clean this up a little bit, because if you see 4 divided by 2 is just 2, right? So then this would be equal to 4 cos of 2 pi. Just looks a little nicer than the fraction, but unfortunately this has to stay. So multiplied by the cos of pi over 2, figure out what that value is, and then square it. Subtract 2, sine pi over 2, I can't clean up. I'm waiting to get all the way over here, yep. And then multiplied by cos of pi over 2, multiplied by the sine of, again, 4 divided by 2 would be 2 pi. As my angle, leave it in brackets. Now, in the last video, I said to have your 4.1 worksheet out or open on your computer as a PDF file, or if you have a printed version, it would be even better, I think, out in front of you physically. I would ask you now to do the same thing. Sorry, I didn't mention that at the beginning of the video, because if I'm looking at 90 degrees here, and in some cases, so that's pi over 2, right? 180 divided by 2 is 90 degrees, or I also have what's double pi? What's double 180? 360. When I was looking at the special triangles, it's because I didn't see those values on my sine or cos curve. Here I have both sine and cos. So on those sinusoidal functions, though, I do have those values on my graph already. So I can just get the values off of the graph. So what I mean is, for example, this would be 4 times, what is the cos of 2 pi? So go and find your original cos function. So if I look at 4.1, the second graph, my original cos function, and find it at 2 pi. So if I look at 2 pi, do you see how there the value is 1? The cos of 2 pi is 1. So that's this whole part here. Now, what's the cos at 90 degrees? Cos at pi over 2. So at that cos curve, I go to pi over 2, and I have 0. And then I would just square it. So this is all multiplied by 0 squared, right? Now I'm over here, minus 2 times whatever the sine is of 90 degrees. So be careful that you look at, now I have to switch to the sine curve, right? So go up to 4.1 in the first one. Your sine curve at pi over 2, 90 degrees is 0. So negative 2 times 0. And then don't forget to switch to the cos curve at 90 degrees. Pi over 2 is, so wait, I've got sine here just to double check. Something doesn't seem right since cos is 0. So let's go back to my sine, starting at 0. At pi over 2, yeah, I did make a mistake. That's 1. So go back to your sine curve at 90 degrees. It should be 1. Right here, sine of pi over 2. This is not right. So change that to 1, because then, sorry, when I looked at cos of 90 degrees, cos curve 90 degrees, pi over 2, that one is 0 times 0 times this sine of 2 pi. So go back up to your sine curve. Let's be careful. Find 2 pi, and that is 0. So if we do all this, 0 squared is 0. 0 times 1 is 0 times 4 is 0 minus 0 times 0 times negative 2, right? Or 2 times 0 times 0 is just going to be 0, and my answer is 0. So my derivative is 0, which is the slope of the tangent of the equation I'm trying to find. So that slope is 0. So with my y equals mx plus b, that's supposed to be a plus. I've got y equals 0x plus b. So again, 0 times x. So far, y is just going to be b, but I need to figure out what my y value is. So like I said, kind of at the beginning of the video there, I need to figure out what my y value is. So I'm going to go take my original function, copy that out. I'm going to clear this screen, so just make sure you've got that. Write out the original function and plug in pi over 2n for x to get my y value. So y equals the sine of 4 times pi over 2. Multiplied by, remember how that was cos of x and then squared? So cos of pi over 2, get that value, and then square the entire thing. So again, this is 4 divided by 2. So just to simplify, that could be sine of 4 divided by 2 is 2 pi by the same thing, multiplied by cos of pi over 2, that value squared. They're multiplied by each other. So what's the sine of 2 pi? So again, if I go to my sine curve from 4.1, go to 2 pi, be careful, double check it, 0 times. What's cos of 90 degrees? Go to my cos curve, go to 90 degrees or pi over 2, and I get 0 as well, squared. So again, 0 squared times 0, my y value is 0. That's what I've got. So going back to my y equals mx plus b, my y is 0. My slope of the tangent, if you remember, was 0. Just going back to double check, yeah. My x value is pi over 2 plus b, but I've got 0 equals 0 plus b. So my b value is equal to 0. Whether you bring that over, whatever the case is, my y-intercept is at 0. So now for my equation, just to change the color, y equals mx plus b, right? It's asked for the equation of the line that is tangent to, so the equation of the tangent line. So this is my sinusoidal function. This is my curve. I want to look exactly at 90 degrees at pi over 2. And what would be the equation of the line that is tangent to that function? So again, I leave y and x. I sub in my m, my slope value, which is not on here, but the previous screen was 0, times x plus my b value of 0. So 0 times x, right, is 0 plus 0. My equation, I know it looks weird, but this is an equation. Does that kind of send you any alert from grade 9? This is my equation. This is my y equals mx plus b. It just looks like y equals 0. So this is the equation, just to point out here, this is the equation of the tangent line. So what does that mean if we think about it? This is the equation of the tangent line, which is a, do you remember grade 9 we had special equations, x equals a number and y equals a number. X equals a number, just again, not part of this note, but would be a vertical line, right? And it's x equals, let's say, because you've got, for me, it crosses your x-axis is how you can remember that. And then your y equals a number. If this was my axes, x and y axis would be whatever horizontal line crossing the y-axis. So it's y equals a number. So this is a horizontal line sitting on the x-axis. So this is a horizontal line at 0. So all along y. So let's just say for this particular case, it would look, but the equation of the tangent line, so if this was my function, I know that my equation of the tangent line is a horizontal line. So if something's a horizontal line and has a slope of 0, we know that's happening at like a turning point, right, in the curve. So that's my equation.